All right, we are going to cover lecture 3 today on strings and lists. So again, we're going to start our terminal, and this gets us to the command line interface. And we will start the Python interpreter by typing Python 3. And now we can see we're running the Anaconda version of Python, and we're in the interpreter because we see the 3 greater than sign at the prompt. So in the previous lecture, we went over some of the basics of running Python and just using it as a calculator, and then also starting to get into the process of creating variables and how the process of creating variables creates specific types of objects. So we covered the numerical objects in the previous lecture, and we looked at booleans, integers, floats, and then complex numbers. So Python defines these classes in the source interpreter, and Python also includes a number of other useful built-in types for storing data. So we're going to cover 2 more of those built-in types, and those are called strings and lists. And strings and lists are a little bit different than the number classes that we saw, because they're actually something called containers, and sometimes they're called sequences in other programming languages. And so they're different because they not only hold data, but they actually hold multiple values of data. And so for this reason, they're called containers. There are some other containers that we're going to study later, tuples, dictionaries, and sets. Strings and lists are just a subclass of these containers, and they're also known as sequences. So containers hold multiple elements of data. Sequences not only are containers, but they also have specific orders. So as an example, let's create a string. So strings are perhaps words and phrases, and you can't mix up the letters and expect the word to remain the same. The same is actually true of lists as well. So strings, some examples. Maybe you create a string object in order to contain DNA sequence information. So you have a run of nucleotides, ATAACCGTA, GACCGT. And so, we can create a string by using the single quote characters, and then everything that we want within that string is within those 2 single quote characters. So let's say we do something like this. All right, so now we have a string object that we created. How do we know it's a string class? We use the type command. Lo and behold, the class that we created is string. And so I know that if you use the single parentheses, Python implicitly will create a string type object. So what do I mean by the order is important? Well, order is important because these 2 sequences both have 3 A's, 1 T, and 1 C, but they're clearly different. They're different sequences, and so that's what I mean just by order is important. All right, so you can also create an empty string, or you could create, for example, a name. And so this is 2 words, Patrick McGrath, separated by a space, but it's a single object, and the space is part of the object. All right, we can print. We used the print command in the previous lecture, so we can print that out, and we see it looks a little bit different. It no longer has the single quote characters. So there's actually 3 different ways to implicitly create a string. So the first way is to use the single quote characters. The second way is to use double quote characters. Sorry. This is probably going to be a problem. Or we can actually use 3 double quotes at the same time. In all 3 cases, we create a string type object. So you can't mix and match the different ways. So we can't do something like this where we start the string with a single quote and then we end it with a double quote. This is a syntax error, so Python gets confused because they see the single quote and it starts to create the string, but it's not going to stop the string until it sees another single quote. And so this is an example of a syntax error. All right, so why do you have all of these different ways to create a string? This becomes obvious once you think about the fact that you might want to have a single quote or a double quote within the string object itself. So what's an example of that? So an example of that is if you have a contraction. So she'll be coming around the mountain when she comes. So you might want to store this phrase. This is a song lyric. And so if you use the single quotes, what's going to happen when you try to do that? Well, you get a syntax error. And so why does this confuse Python? This confuses Python because it sees the single quote and it wants to start to create a string, and it starts to read until it reaches the next single quote. And so what it's done is it's stored she as the phrase. It wants to store she as the phrase because everything in between the single quotes is what it stores as the string object. But now there's all this extra junk after that. So all of this comes after that, and Python doesn't really know what you're trying to do. So it gets confused and you see a syntax error, and then you can see the location of the syntax error by this caret signal underneath it, and that shows you where exactly the syntax error occurs. So we can see this is where Python gets confused. Up to here, something like this is totally fine, so we could do something like this. And Python would be totally fine with it, but now once we add additional characters after that, this is where it gets confused. So that's a syntax error. So this is where you might want to use the double quotes. So why does the double quotes work? Let's see if it does first. All right, the double quotes, we are able to successfully store this whole sentence as a single object, and we can just verify that it is a string object. So it works because Python sees the double quotes. It says, all right, create a string type object, and then it reads through this until it finds another double quote, and that doesn't come until the end. And so now the syntax of it makes sense, and it correctly uses this apostrophe and puts this as part of the string type object. Maybe you want to have a sentence with a double quote character. So if you want to read Watership Down, which is a children's book about bunny rabbits, very good book, I would recommend it. So let's say I wanted to store this as the entire phrase. Titles, book titles are often enclosed in quotes, and so that's why I've included the quotes there. So if we use the double quotes in this situation, we get a syntax error. So again, Python reads the double quote. It sees, okay, this is the start of a string object, and it's going to go along until it reaches the next double quote. And so this occurs right here, and then it gets confused by the remaining text in this line, and so we can see the syntax error occurs here. So in this case, we can solve it by using the single quotes instead. And we are golden now, and we have managed to successfully store that as a string type object, and the double quotes are within there. You also might have like a so you might also have a quote, listen to the lecture, said the professor, and how do you store that? Again, you can just use the single quotes now instead, and the double quotes are properly stored as part of the string object. What if you want both single quote and double quotes within the string object? So an example of that, it's fun to read Watership Down. So now we have both single quotes within there and double quotes within there. So, for example, if we try to use single quotes, we get an error. If we try to use double quotes, we get an error. And so it reads in until it sees the next single quote. The syntax error occurs here. If we try to use double quotes, it reads until it reaches the first double quote, and then it has the syntax error here. So this is where the triple quotes might be useful. So now we can successfully store it. And so you actually see that there's this / to make it clear that this apostrophe is part of the object itself. This, using either single quotes, double quotes, or 3 double quotes together, will allow you to store pretty much every single string that you want. One final exception that just is kind of for fun is, let's say I wanted to do something like this. So again, we have a single apostrophe, and we're also using the double quote. And what happens, how do we store this? So you might say, okay, I want to use the 3 quotes. So we get a syntax error. And the reason for this is now we've opened up the string by saying, look for 3 double quotes in a row. But Python gets confused because it sees these 3 double quotes and it doesn't know how to parse this. Do we want this to be the 3 double quotes in order to close the object, or do we want these 3 quotes to close the object and include this as part of the string? So there's ambiguity there, and Python doesn't know how to handle that. So one final thing you can do is actually use a escape character. So we saw how you could use an escape character at the command line, and the escape character allows us to use a space, for example, as part of a name of a file or a name of a folder. And so now we're able to do this. So how does it read this? It sees, okay, 3 triple quotes in a row. So we open the object, we create the object. It's fun to read Watership Down, and then it knows this is actually what we're trying to create it as, is just a single quote object. And then these 3 are going to be interpreted as the close of the string. All right, so this is kind of the basics first for how do you create a string implicitly, using either the single quotes, the double quotes, or the triple quotes all together. And you can also explicitly create a string if you wanted to. We saw before that you can always use the name of the class to ever explicitly create something, create an object. But note, you still have to use the quotes in order to do that. So Python is not smart enough to simply take the text that you want to store and do it that way. So in general, it's just always easier to kind of implicitly create a string. All right, so that covers the first part of the lecture, and then next we'll cover how we can use some certain functions in order to read in strings, and then also kind of the methods that are associated with a string class.